Good evening, guys. Welcome back to my channel. So, last video we saw about the introduction to the probability distributions, and I also told that you should have studied already about the basic probability, conditional probability, etc. Now we will start with the distributions part. Okay. So, for any distributions, first of all, I tell you what is distribution. Okay. So we saw the PMF, right, in the last video. So whenever the random variable is distributed like a function, it is called a distribution. So last video we saw about the coin toss example, right? So for when you toss two coins, and if you choose the random variable as x, where x represents getting heads. So for x equal to 0, we got the probability 1 by 4. For x equal to 1, we got 1 by 4. Sorry, 1 by 2. And for x equal to 2, again we got 1 by 4. Right. So this is looking like a function, right? So wherein the input is the random variable's value and the output is a probability. So that is called a distribution. So generally distributions can be split into two parts. One is discrete distribution, another one is continuous distribution. Okay. What is discrete? What is continuous? So when you talk of discrete distribution, it means that the random variables can take only discrete values. What is discrete values? Like let's say integers, 0, 1, 2, 3, etc. And what about continuous? Continuous can take any values ranging from minus infinity to plus infinity. Okay. So here the discrete values can be 0, 1, etc., etc. And so by 0, 1, I mean it cannot be 0.5 or 0.55 or anything like that. Okay. So but in the continuous part you can have anything between minus infinity to plus infinity. Okay. So when if you want some example, I can tell for discrete, you can tell you can keep the coin toss example itself. Okay. So when you take tossing of two coins and you take getting heads as a random variable, you cannot get a half head, right? If when you toss two coins, you cannot get half heads or 1 by 4 heads. So which means that is a discrete distribution. And in the continuous part, if you see, let's say you are choosing a class and you want to know the probability that the height of the students are between, let's say, 50 centimeter to 100 centimeter. The students can be of any height. It can be 50, 50.5, 50.25, anything. It's not necessary that it should be only 50, 51, 52, right? So that is the meaning of continuous distribution. When you speak of discrete, you have binomial, Poisson, geometric, negative binomial, etc. When you talk of continuous, you have normal, uniform, uh, etc. So the important point here is all these distributions are generalized distribution. So in your real life example, when you have some problem, let's say, so you have to think of which distribution to apply. So first you have to identify if it is discrete or continuous, and then you have to think of it if it this follows binomial distribution or if this follows Poisson distributions, like that. Okay. So first we will start with binomial distribution. So what is binomial distribution? I think you would have heard of the term binomial at least. In 11th standard, 11th grade, you study a chapter called binomial theorem, right? I will just give a revision on binomial theorem. This is the expansion. Do you remember? X plus y power n is equal to nc0 x power 0 y power n plus nc1 x power 1 y power n minus 1, so on. Correct. This is the expansion of binomial theorem. Similarly, there is some relation to there's some relation between binomial theorem and binomial distribution. That's why the name binomial is given to this also. Whenever an experiment is conducted, you should have just two outcomes. Okay. Like it should be either a success mentioned by represented by P, or a failure which is represented by Q. Okay. Sorry. So when you speak of a coin toss example, if getting one heads in two coins toss, two when you toss two coins, let's say getting one head is a success, not getting one head will be the failure. Okay, so there's no other possibilities. I mean, there can be other possibilities, but you add all that up and put it as a cube. Okay, so for example, when you tell in the toss of a coin, getting number of heads, so let's say getting number of one head. Okay, that is the success probability is p. What is the probability that you get one head in toss of two coins? It is 1 by 2 by 4, right? It can be ht or th, correct? So that's 2 by 4. Now what is the q value? Even though there can be other possibilities like getting two heads or getting no head, there are other possibilities, but you add all that up and subtract it with this p and you get q, that's all. So if you add everything, you get 1, because the total probability is 1. 1 minus 2 by 4 will be what? uh, 2 by 4 again. This 2 by 4 is not the probability of only one event, understood? That is the probability of the, like, you can tell it is a complement. P is the complement of q, both are opposite of each other, and thus we can tell the this equation always holds that p plus q will always be equal to 1, understood? So this is one important condition for a binomial distribution. So we have other conditions yeah, in order to satisfy the binomial distribution. Like in order, if we have to check if the the distribution is binomial or not, we have other conditions to follow also. Okay. And the second condition is to check if the number of trials is fixed or not. What is number of trials? So let's say you're tossing dice 10 times. Okay. So that is the number of experiments you perform, and it's represented by n. Okay, so that is the n here in this binomial theorem. Okay, so if the number of trials is fixed, only then you can apply binomial distribution. You cannot change the number of trials then and there. Okay, so here in our coin cost example, that is n is 2 because you're tossing 2 times. If you toss dice for 10 times, then that is n. Okay, so here this will be considered as the number of trials. Number of trials is fixed. Okay, you cannot change the trials as and when you want. That is the second condition. Third condition is the trial should be independent. So what does it mean by independent? You would have studied that previously, independence theorem, which means that every event is independent of each other. So there is no condition on which the events are happening. Let's say when you are rolling a die, it is not like you will roll the dice next time only when you get one in the first chance. No, nothing like that. Okay, when you don't have, impose any condition on the events, that's called independent events. Okay, if you want to tell mathematically, remember p of a by b is the conditional probability. When you have the dependence, like when you have to find the probability of a, given that b has already happened, which means a event a is depending on the outcome of event b. That's not going to happen here. This will be only solely dependent on a alone. So which you can tell as p of a itself. Okay, otherwise the formula will change. Generally, if you want to say the dependency, the formula will be what you remember, right? P of a intersection b by p of b. That is the conditional probability formula. But here there is no such formula because there is only so there is only sole dependency on a event a only. So this will result in p of a itself. That is the another condition, which is what? Independence. And the last condition to check is the probability of success, which we told as p, is always fixed. It's not that you can change the probability of success every time you perform the experiment. Okay, so let's say in the die example again, if you roll a die once, the probability of getting 6 is 1 by 6, correct? There are 6 numbers. Probability of getting 6 is 1 by 6. That is fixed. Every time you roll a die, it will be 1 by 6 only. You cannot change the die, or you cannot use an unbiased die in the fifth trial and biased die in sixth trial, like that. No, it's not allowed. Always p is fixed. Okay, so these four conditions, if you see anywhere, then you can tell easily that binomial distribution is going to apply. Okay, so remember these conditions. One second. Okay, so I will just put it in red color so that you can understand. So this one condition is success and failure, and when you add success and failure, you'll get one. This will be very useful. Okay, and one more thing is number of trials is fixed. and the trials are independent, and the probability of success is also fixed. Understood? So now we will see what is the actual formula itself. Okay. Now, before that, for any distribution to take place, at least for these videos, we will see the following things. Okay. One is the condition. What is condition? The condition under which the distribution can apply. That is the condition. Second is the PMF. What is the actual probability mass function that the distribution takes? Third is CDF. Even though CDF has no formula, we'll see how to calculate CDF with using the PMF. Okay. And fourth is the mean, and fifth is the variance. Okay. By variance I mean standard deviation also. Okay. So these five things we will see for every distribution along with the proof. Okay. So in our case, condition is over. Correct. Condition part is over. Okay. Now we'll see the PMF. Okay. PMF. I already told you the binomial theorem. It is similar to that only. So when you for any experiment, when there is a n when there is n number of experiments, and you have to find the probability that x has happened. Let's say you are rolling dice 10 times, and you want to know the probability that 2 times 6 has appeared. So that 2 is x, and the total number of experiments you had performed is n. Okay, now probability of x is equal to x. Okay, this x is the number. Okay, let's say this is the x, and there's a probability of success is p, and so is q, which is 1 minus p. Okay, so a probability of random variable x, which is equal to x. In our case, probability of getting two heads, which means probability of getting head is the random variable, and number two is the small x. Okay, number two small x. So it will be ncx p power x q power n minus x. That's all. This is the probability mass function for the binomial distribution. Okay. So whatever the number of trials they give, that is n, and what probability you have to find, that will be x, and p is the success probability, q is the failure probability. That's all. And if you want to calculate the CDF, it is very easy, right? Because so if CDF is calculated by f of x, it is nothing but f of x less than and equal to x. That's all. So sorry, sigma will come. So you apply the sigma ncx p power x q power n minus x from 0 to the x they give. Okay, this is a CDF. Simple. We'll solve examples. Don't worry. Okay. So I'm just telling you the formula how to apply. Okay. Now we'll move on to the mean. Okay. So mean part. What is the formula for mean we studied in the last lecture? Mean is equal to just E of x is equal to sigma x into f of x. Correct? Correct. Sorry. This is the formula for mean. What is I'm not writing the limits. Okay, it's always 0 to n, at least in discrete distribution. Now x into ncx p power x q power n minus x. Correct. Now I will expand this ncx. How to expand ncx? Oh, that I forgot to tell. You know, right? Uh, ncx nothing but n factorial by x factorial into n minus x factorial. Correct. So this part we have studied in the binomial distribution, binomial theorem, right? So this I'm writing it here: n factorial by x factorial into n minus x factorial into p power x to q power n minus x. Okay. Now, we have to we can cancel this x, right? What will remain? N factorial by, if you cancel x factorial from if you cancel x from x factorial, x minus 1 will remain. Correct. 1 factorial n minus x factorial into p power x into q power n minus x. Got it. Now Just do one thing, okay? Just take n outside, n is a constant, and also take p outside. Now what will remain here? Remaining will be n minus 1 factorial. P power x, if you take p from p power x, p power x minus 1 will remain. Q power n minus x divided by x minus 1 factorial into n minus x factorial. Now, can you see this formula? Have you seen this anywhere? When you open NCX, what will you get? When you open x plus y power n, we saw in the formula, right? Sorry. Here we saw, right? Binomial theorem expansion. NC0 x power 0 y power n. Isn't it similar? You're getting, this is nothing but p plus q power n minus 1. Can I tell you how? See, p plus q power x minus 1. P plus q power x minus 1. How will you expand this? X minus 1. Sorry. It's not x minus 1, it's n minus 1. Okay. How will you expand this? N minus 1 c x minus 1 into p power x minus 1 into q power n minus 1 minus x minus 1. Here, your 1 will cancel. So n minus x will remain. Isn't this the same? So it is possible to write this as p plus q power n minus 1. That's my final take from this. So this np, this will be p plus q power n minus 1, correct? Now, p plus q is what? It's 1, right? So we saw this already. Q is equal to 1 minus p. I told in the condition itself. So it's something 1 power n minus 1. 1 power anything is 1. So you get n into p. So guys, so the mean for the binomial distribution is NP, where N is the number of trials performed and P is the success probability. Okay. So next we'll see variance. Just I'll tell you, just I'll revise. Okay. So first we started with the distributions part, and then we and then we saw the binomial distribution, binomial theorem expansion, and we saw the conditions where the binomial distribution can apply. I will write this, okay? Conditions. Okay. Now next we saw the PMF, where the probability mass function is defined as NCX, P power x, Q power n minus x, and then CDF how to calculate. We'll see examples, okay? And then mu also finally, okay? Variance, I'll just tell you. I just wrote it, okay? I'll again write, no, don't worry, okay? So this is the mean and variance. Now before going to the variance part, I'll just tell you the one intuition, okay? I had the question somewhere here. Okay, so here, okay. So binomial distribution is okay, it's fine, everything is cool. But when you directly apply formula, you won't get the feel of how the formula came, or even though it is binomial expansion itself, we have to think of how the formula came. Okay, for that, I'll tell you the intuition from this question. Okay, I'll write it down again. Anyways, examples again I'll solve separately in some other the next video. But before that, I wanted to give this. This was an example from a book, but for the intuition purpose, I took this example. Okay. So now, what study the question? The chance that a bit transmitted through a digital transmission channel is received in error is 0.1. Also assume the transmission trials are independent. See the conditions they gave. Transmission trials are independent, and probability success probability they gave 0.1, and we have to find the p of x equal to 2. What? But that they've given the random variable. Every time you do a question on distribution, define the random variable initially. Okay, let x is equal to the number of bits in error in the next 4 bits. What is actually happening? There is a channel. Okay, some channel, let's say it's a wire. Okay, for easy purpose. Okay, now when you send a bit here, you will receive the bit here, sending and receiving. Okay, but if it's not necessary, it's not always necessary that the output bit will be same as the input bit. It can result in some error also. Okay, that's what they're given. That probability of getting that error is 0.1. And now the random variable is defined as the number of bits in error in the next 4 bits transmitted. which means they already calculated the probability as 0.1, okay, doing some experiments. Now 4 bits they're going to send, okay. In that 4 bits we have to determine the probability 2 will result in error, okay. Now if you directly apply formula, you'll get n is if n is equal to 4, so 4c2 directly. Now p power 2 q power 4 minus 2 second 2, this is the answer, that is fine. But what is the intuition here, how this formula came, okay. Now let us say the probability that error doesn't occur is a 0, and the probability error occurs is 1, okay. That's what we do, right, in the binary system, 0 and 1. So totally 4 bits are transmitted, so how many combinations will come? 2 power 4, which is 16, correct. So 16 combinations you have to write, okay. 0, just write it along with me if you want, okay. Now this is how you write the in your computer science, if you have studied computer science, this is how you write sorry, not computer science, computer science will come, but I think the truth table in your digital electronics, this is how you write, no. 16 combinations is very rare to get, but in case you studied, this is how you write the table, okay. Just give me a second, I'll finish this. So this is over. Now final thing is 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1, done. Okay, this is the 16 combinations. The next 4 bits can be of any of under this 16, only 16 possibilities are there, okay. Now this is what in binary, if you want, this is 0, this is 1, this is 2, finally this the finally all ones are nothing but 16, okay. Just this and right, okay. 1 1 1 1 is what, 16, no. So now what we want, determine p of x equal to 2, which means we have to get two bits as error. Error is what, 0. Find the combinations where two things are zeros. Here this is one combination, I put it that. This is one combination, this is another, this is another, this is one more, this is one more. I will let left something else. Here, this is one more. 0011 is one combination. 0101, 0110, 1001, 1010. Finally, 1100. Only six possible combinations will be there. You can check it. Okay. Only six possible combinations there where two bits are resulting in error. So all these six combinations. Now, can you relate to it a bit? This is why four. Do you know what the value of 4C2? 4C2 is 4 factorial by 2 factorial by 2 into 2 factorial. Nothing but 4 into 3 by 2. One will go here. 4 into 3 is 12, by 2 is 6. Now can you see where the 6 came from? Now I'll write the combinations. Instead of writing it, we'll just see, okay. All these six, if you arrange, in any order, okay, with in any order does not matter, okay. If you arranged in any random order, you will eventually get one among these itself. Let's say 0011 is the combination. If you arrange 0011 in any order possible, you will result in other five, any one among the five, right? So, and because the trials are independent, we can we have to find this probability. So we can directly do independence formula. This is p of 0 into p of 0 into p of 1 into p of y. I already told you, because there's no dependency, we can directly multiply the individual probabilities. If you want to revise that, go to multiplication theorem and independence in the lower classes. What is probability between 0? 0 is what? Error. Error bit is 0.1. So 0.1 into 0.1, which is 0.1 the whole square. And probability of getting a correct bit. Correct is what? 1 minus 0.1. That is the failure. So 0.9 again square. Now, but 0011 is not the only possible way, right? You can arrange it in any way, any number of ways. How many total ways you can arrange? There are totally 4 bits, and you want these two should remain, like you want 2 bits to result in error. So 4C2, this is how you arrange, right? So you can when you simply arrange, you will get all the 16 combinations again. That's not what you want. If you arrange this whole 0011, where only two zeros will be present, okay, that case, if you want to take will result in 4C2, correct? Now this 4C2 is already there, which is 6. Into this probability will come 0.1 square into 0.9 square. Can you see the formula how it came? See, this is nothing but 4C2 p square q square. This is why binomial distribution is it came from binomial theorem. The arrangement. So whenever the n number of trials is given, here the n is 4. Out of 4 trials, you want 2 should out of 4 no, bits. Sorry, trials means bits. Okay, here in this case it's bits. Out of 4 bits, 2 bits should result in error. How will you? What is the What is the possible combinations? It's just 4C2, right? 4C2, if you do, there are 6 total combinations in which 2 will result in 0. That is what I've done here, right? The 6 combinations. See, this 6 combination is nothing but 4C2. Okay. Now the probability of getting 2 bits error simply in one combination alone is nothing but 0.1 square into 0.9 square. And totally 6 combinations are there. So that's why you're multiplying with 6. That is the formula also. 4C2 into p square into q square. Got it? It's as simple as that. Okay. If you have any doubts, you can ask in the comments. Okay. Now, next we'll proceed with the variance. Before that, I just wanted to give this intuition. I thought of giving it before mean itself, but anyways, so this was a mean part that I told in the beginning. Now this is the example part. Okay. We'll just continue with the variance now. So next we will calculate the variance. Okay. Now variance is, what is the formula for variance? It's e of x square minus e of x the whole square, right? So I'll do a small tweaking over here. I'll tell you why I did also. Now e of x square can be written as x into x minus 1. So this will be x square minus x, right? Now we'll want a plus x to cancel this x. So am I right? So this part is correct, right? So this is still equivalent to e of x square. Now you can do e of x the whole square. So this is right, and so the property of expectation is nothing but you can bring this inside, okay, like this. So when it is e of x plus y, there are two random variables. We can do e of x plus e of y possible, okay. So I'm doing similar thing here. So e of x into x minus 1 plus e of x minus e of x the whole square. Understood? So now we will start the calculation. Now I will just calculate the e of x into x minus 1 part alone, because e of x, this is mean, and e of x of whole square also, it's mean square, right? So this will be equivalent to sigma x equal to 0 to n x into x minus 1 into ncx p power x q power n minus x, right? So it can be written as, I will not write the limits again. So x into x minus 1 into n factorial by x factorial into n minus x factorial into p power x into q power n minus x. Okay, I'm just expanding the ncx part. Similarly, now we will do, we'll take n outside, so n outside, p outside, and we'll do sigma, sorry I forgot sigma here. Sigma x into x minus 1 by x into x minus 1 into x minus 2. Understood? I'll do it in the next part, next step. Okay, so and a factorial p power x into q power n minus x. Now do you understand why I did this here? So if you the previous step, it's not previous mean when we were calculating, it was just it is just x. Okay, so you could have cancelled easily that with x minus x into x minus 1 factorial, and you could have cancelled x. But here, if you directly did e of x square, you will do x square into f of x, right? If you directly did instead of expanding this will be what, x square will be there, but n factorial by x factorial into n minus x factorial. But How will you cancel this? How will you remove this x factorial here? If you do x as x into x minus 1 into x minus 2, it will only cancel one x. What about the x minus 1? That is why I did this previous, this one, and used that to calculate this one. Understood? So now you can easily cancel x into x minus 1. Now here we got x minus 2. Previously we got x minus 1. I forgot the n factorial. So we can write this as, after this go here, okay? We can write this as sigma. N factorial can be written as what? N into, similarly, n into n minus 1 into n minus 2 factorial. I'm again trying to do the same thing, understood? Sorry, I forgot the n minus x factorial part. It is still there, no? So n minus x factorial. Now I want p per x is there. So I'll do it as p power x minus 2. So what will be taken out? Say p square, because p square into p power x minus 2 is p power x, right? So now q power n minus x stays. Similar to how we did the variance, do mean, do the variance also. Replace n with, we have replaced n with, it looks like we have replaced n with n minus 2, x with x minus 2, right? So we can write n into n minus 1 into p square. The sigma can be written as, sorry, sigma can be written as, the sigma part is there, no? This part. This can be written as what? P plus q power n minus 2. Want to make to expand? I'll do it, no problem. So n minus 2, c x minus 2, p power x minus 2, and q power n minus, sorry, yeah, n minus 2 minus x plus 2 will come, no? So 2 can cancel, so n minus 6 is there. It is still there. Understood? So this is what you do. Now you do n into n minus 1 p square into p plus q power n minus 2. What is p plus q? You know it is 1. So the answer is n into n minus 1 into p square. Remember, this is not variance. We only calculated e of x into x minus 1. Now we have variance is equal to this e of x into x minus 1 is there, plus or minus what? Plus e of x minus e of x the whole square. Understood? So this will be n into n minus 1 into p square plus e of x is mu. Mu is what? Np minus e of x the whole square is n square p square. Now n square p square minus np square plus np minus n square p square. Just opening the brackets. Okay, this part I have written. N square p square will cancelled. Now it is np minus np square. So if you take common np as common, you get np of 1 minus p. What is 1 minus p? You know p plus q is 1. So 1 minus p will be q. So you will get npq. Got it? So what is the variance? Final variance formula is npq. Understood? So if you want to calculate the standard deviation, do root of npq. That's all. Root of npq will be standard deviation. So understood? So I will just revise it once. If you want to calculate summary, let's say it's summary. Conditions I told you, all the 4 conditions, refer it up in the above page. So that is a condition. And PMF I told what? NCX q power x, sorry, p power x, q power n minus x. And CDF I told you how to calculate it. It is nothing but f of x less than equal to x, and sigma will come. So next is mean. Mu is nothing but n into p, and the variance is nothing but n into p into q. The conditions, one part I forgot to tell. One is nothing but the number of trials is fixed. Second is there are only 2 outcomes, P and Q, success and failure, and the summation is 1. Another is the probability of success in each trial will be same. You cannot change. So when you roll a die, probability of getting 6 is 1 by 6. Every time you roll a die, the probability of getting 6 will be 1 by 6 only. It cannot change. Okay, that condition I missed in the this part when I was telling you the conditions in the binomial theorem. I forgot to tell. This was the sorry. This was one more condition. Okay, trial should be independent. I told T is probability of success should be constant. It cannot change with time as in every time you do that experiment, it cannot change. Okay, this is the important step. So we started with binomial expansion revision, and we did the conditions for binomial distribution. And I just showed you how to calculate with using one example and one real-time example. So I told getting 3 6s out of 10 roll of die, or getting two heads out of three times tossing a coin. Anything is fine. And the PMF I told how to calculate. The CDF also I told. And then the mean calculation I told. The proof it is NP. And the variance is NPQ. I calculated and show you. Remember, you have to remember the NP and NPQ. And we summarized also. So that's all about the binomial distribution. We'll do examples in the next video, no problem, no worries. So if you have any doubt, you can ask me in the comments. So thank you guys for watching. I think everything is smooth in the teaching part. If you have any suggestions, please let me know. So thank you guys. Bye.